Welcome class 12th. Today we will discuss the topic preparation of colloids. As in our previous video, we have already discussed the classification of colloids. Now here it is time to prepare the colloids. So let's start. So firstly, preparation of lyophilic colloids. The lyophilic colloids have strong affinity between particles of dispersed phase and dispersion medium. Therefore, these colloidal solutions are radially formed by simple mixing the dispersed phase and the dispersion medium under ordinary condition. As we all know that lyo means liquid and philic means affection. So lyophilic colloids have a great affection between the dispersed phase and dispersion medium, and due to this the lyophilic colloids can be easily prepared under simple ordinary conditions. As we have prepared lyophilic colloids, because lyophilic colloids can be easily prepared by simple mixing of dispersed phase and dispersion medium, because there is much affinity between these two phases, dispersed phase and dispersion medium. Now our task is to prepare the colloids of lyophobic colloids. Since lyo means liquid and phobic means heating, we have to prepare the colloids which are liquid heating in nature. So these liquids or these colloids or sols can be prepared mainly by two methods. One is condensation method or aggregation method. Second is dispersion method or disintegration method. So first of all, condensation methods. In condensation method, we will discuss chemical reaction. In under condensation method, we will discuss chemical reactions. And in chemical reaction, first is oxidation. A colloidal sol of sulfur obtained by bubbling H2S gas through a solution of bromine water, sulfur dioxide, etc. So let's see first reaction. H2S gas combines with bromine water. It forms HBr plus sol of sulfur. Here, by using oxidizing agent, by using bromine water, H2S gas can convert it into sulfur sol. Similarly, on using SO2 sulfur dioxide, H2S gas can convert it again into sulfur sol. So this is the oxidation method or the process for converting or for preparing the lyophilic colloid. Come to the next chemical method, reduction. Salt of gold, when it combines with formaldehyde HCHO, it is used as a reducing agent here, and plus water, it will reduce and they form, it will reduce gold to gold sol and forms formic acid HCOOH plus 6 of HCl molecule. So this is the reduction process for of gold salts, in which gold salts can convert it into gold colloid of gold, that is gold sol, solution of gold. When salt of gold or salt of some other metal combines with formaldehyde HCHO in the presence of water, they will reduce the metal to its sol and it will produce HCOOH, formic acid, and with HCl. Next chemical method is hydrolysis. A colloidal solution of ferric hydroxide is prepared when concentrated solution of ferric chloride is added dropwise to hot water. If we have ferric chloride and if we added water, hot water to this ferric chloride solution, then we will get the solution or the colloidal solution of ferric hydroxide FeOH whole thrice. And this ferric hydroxide will be a lyophobic sol or will be a lyophobic colloid of ferric hydroxide. Next chemical method is double decomposition. Arsenic trisulfide As2S3 is obtained by passing H2S gas through dilute solution of arsenious oxide H2S2SO3 in water. As we pass H2S gas in arsenious oxide As2O3, we will get a colloidal sol of arsenic trisulfide AS2S3. So these are the chemical methods for the preparation of lyophobic sols or the lyophobic colloids. Now come to the next method of preparation of lyophobic colloid, that is dispersion method or disintegration method. In this part, we will discuss two types of the method. One is electrical disintegration or known as Briggs arc method, and other one is peptidization method. So first of all, we will here discuss about electrical disintegration method, or it is also known as Briggs arc method. This method is used to prepare the soles of metals such as platinum, silver, copper or gold. And in this method, an electrical arc is struck between electrodes of the metal which is immersed in the dispersion medium. Suppose here it is in the structure, in the image also we can see that if I have a container and in this container dispersion medium is present. This is dispersion medium and two electrodes are dipped. Two electrodes of metal are dipped in this solution or in this dispersion medium, and they both are connected with the electricity. They are connected with wires. This end is negative end and one end is positive end. Now this container will be now placed with some outer container, and that outer container will contain ice bath. Now what will happen if we have to prepare the sole of gold? Suppose we have to prepare the sole of gold. Then the electrode which are dipped in this dispersion medium, that must be of gold electrode. The rods of gold must be dipped in this dispersion medium. Now what will happen as the reaction starts, as the flow of electrons starts from the negative terminal, as the negative terminal is at anode and the positive is as cathode, as the flow of electrons starts, the gold will get deposited, will remove from the electrode, the gold will come out from the electrode, from the anode electrode, and what will happen, this gold and the temperature for this reaction, the temperature will be very high and they will generate an electrical arc between these two electrodes. An electrical arc will generate between these two electrodes. इलेक्ट्रिसिटी जैसे इलेक्ट्रॉन्स का फ्लो स्टार्ट होगा तो एक इलेक्ट्रिकल आर्क जनरेट हो जाएगा. एक आर्क के फॉर्म में हमें इलेक्ट्रिसिटी वहां पे हमें मेंशन हो जाएगी दो इलेक्ट्रोड्स के बीच में, और उसी को हम बोलते हैं इलेक्ट्रिकल आर्क. और उसके डेवलप होने से जो गोल्ड का एवोपरेशन है, दैट एवोपरेशन ऑफ गोल्ड कैन टेक्स प्लेस. जो गोल्ड निकला था इलेक्ट्रोड से वो गोल्ड एवोपरेट हो सकता है. And to avoid that evaporation of gold, because we have to prepare the gold sole of gold, and to avoid that evaporation of gold, we put a ice bath, and that ice bath will maintain the temperature between this electrode reaction and the outer atmosphere. और जैसे ये इन दोनों टेम्परेचर को मेंटेन करेगा, सो जो गोल्ड लिबरेट हुआ था इस रॉड से, जो गोल्ड लिबरेट हो रहा था, डेड गोल्ड will be remain in the solution. And in Briggs arc method, two problems are there. One is the evaporation of gold can take place, and other one is if as we are preparing the gold salt, and other problem is that when molecules of gold will come together, they will form a bigger molecule of gold and they will get suspended in the solution. But we know that we have to prepare a colloidal sole, and the size of colloidal sole is in between 1 to 1000 nanometer. And as two gold molecule will come together and they can get suspended and they can form a bigger molecule which will be more than 1000 nanometer. So to avoid this problem, we added in this solution, we added an electrolyte to the dispersion medium. And what will happen, that electrolyte, the ions of that electrolyte will absorb on the surface of the metal. As metal is positively charged, as we are talking about metal, this method is used for making the soles of metal. So the electrolyte which we will add it to the dispersion medium, that charge of that electrolyte, the negative charge of that electrolyte will absorb on the surface of the metal. जितने भी molecules metal के ब्रेक हुए होंगे, उन मॉलिक्यूल्स के सरफेस में जो चार्ज है
इलेक्ट्रोलाइट का जो नेगेटिव चार्ज है वो आके एब्जॉर्ब हो जाएगा। और जैसे ही दो आयंस के बीच में, दो मॉलिक्यूल्स के बीच में जब सेम चार्ज में लाई करेंगे, सपोज गोल्ड था, पॉजिटिवली चार्ज था, तो एब्जॉर्ब नेगेटिव चार्ज इलेक्ट्रोलाइट का इसको एब्जॉर्ब कर लेगा इसके सरफेस को। सिमिलरली ऐसा ही दूसरा पार्टिकल गोल्ड का, उसके भी सराउंड कर लेगा, नेगेटिव चार्ज उसको भी सराउंड कर लेगा। तो दो पार्टिकल्स में रिपल्शन की टेंडेंसी यहाँ पे क्रिएट हो जाएगी। व्हाई? बिकॉज बोथ आर नेगेटिवली चार्ज नाउ and both will repel each other. So due to this repulsion or due to this charge creation on the surface of the metal will get stable or will get suspended, will not form a bigger molecule. So in British arc method we have to resolve two problems in this. First, the evaporation of gold by putting the ice bath, and second is we added electrolyte to avoid the aggregation of the gold molecule, because by aggregation they can form a suspended solution, but we have to form a colloidal solution. So here we added electrolyte so that the charge on the metal now will repel each other and they will get suspended, or they will get remain in the solution, they will not get suspended to form a bigger molecule. So this is all about Briggs arc method. Now come to next disintegration method, that is peptidation. Peptidation is the process of converting freshly prepared precipitate into colloidal form by the addition of a suitable electrolyte is called peptidation. It means in a peptidation process we have required three things. One is freshly prepared precipitate, and that freshly prepared precipitate will get converted into colloidal salt. So for this we have to add a certain or a suitable electrolyte. One is electrolyte, another one is water. So in peptidation method, when an electrolyte is added to a freshly prepared PPT, then what will happen? The suitable ions from the added electrolyte are absorbed by the particles of the precipitate, and the charged particles repel one another and they form a colloidal solution. This can be seen in this example also. Suppose we have the precipitate of FeOH whole thrice. Now what will happen? In this precipitate we will add FeCl3, which is an electrolyte, and for peptidation process the electrolyte should be preferential. It should be based on the nature or the ions. It should be similar with the ions of the precipitate. One ion of the electrolyte should be similar with the ion of the precipitate. So here the electrolyte we are adding is FeCl3 and the precipitate is FeOH whole side. So the common ion in between precipitate and electrolyte is Fe3 positive. So here what will happen? The common ion which will be common in between precipitate and electrolyte, that common ion from the electrolyte will be absorbed on the surface of precipitate. Since here it is Fe3 positive is common, that Fe3 positive will combine or will adsorb on the surface of FeOH whole size. Suppose this is the precipitate. Here it is precipitate, and this precipitate will be surrounded by the Fe3 positive ion, and they will form a colloidal particle. And why we are adding electrolyte here again, and the electrolyte of similar charge or similar ion is adding on the precipitate? Why? Because on addition of similar charge on the precipitate, the precipitate will repel each other and they will not form a bigger molecule. They will form a colloidal solution. They will repel each other and they will get separated from each other so that they will form a colloidal solution here. So this is the peptidation method where the freshly prepared PPT on adding an electrolyte can get converted into a colloidal solution. But the condition must be there that the freshly prepared PPT and the electrolyte must have one common ion. Here the common ion between precipitate and electrolyte is Fe3 positive. So the Fe3 positive will get adsorbed on the surface of precipitate. So the molecules of the precipitate will not form a bigger molecule again. They will form a colloidal particles after settling of the charge in between them, and they will repel from each other. So that's all about the preparation of colloid and the different methods of preparation of colloid. And the next topic we will discuss in our next video. Thank you.